Hi boys and girls. Today we're going to be talking about prime numbers, composite numbers, prime factorization, and exponents. I know we've already gone over this in class before. We just had a unit assessment over it. And so not all of us did all that well. So I'm going to run through a couple of things that you need to remember to make things easier for you going forward. We're getting ready to start adding and subtracting fractions with unlike denominators. And so all of this is going to come in handy for you. Okay, the first thing I want to talk to you about are prime numbers. Prime numbers are numbers like 3, 5, 7, 11, 13, 17, 19, 23. I could go on and on and on and give you lots of examples that are prime numbers. You need to know what makes a prime number a prime number. A good example is the number 3. 3 is a prime number because only two numbers in the whole wide world will multiply together to make the number 3. That's 1 times 3. That's it. 5 is also a prime number because there's only two numbers in the whole wide world that'll multiply together and make the number 5. Same with the number 11. It's prime because only 1 times 11 multiply together to make the number 11. If a number has more than two numbers, two factors that come together and make that number, it's called composite. So if a number is not prime, it has to be composite. If the number is not composite, it has to be prime. The only exception to that rule is the number 1. The number 1 is special. It's unique. It's neither prime nor composite. Remember, a prime number has to have two different numbers that multiply together and make that number. 1 times 1, I know that's the only way to make 1, but are those two different numbers? No, they're not. That's why the number's not prime or composite. All right, so now that we know the differences between prime and composite, let's talk about prime factorization. On your last test, you had some questions about prime factorization. Prime factorization normally comes from a factor tree. But just doing the tree isn't prime factorization. The prime factorization is the long number sentence that you get from making the factor tree. So we're going to see what one of those looks like. I'm going to use an actual number that came off of your test. It's a pretty big number, and so we kind of struggled with that a little bit. The number is 250. This was one of the questions on your last test to show the prime factorization for the number 250. As you know, we need to start off with two branches in our factor tree. Most of you got stuck here because you didn't know the two numbers that multiply together that make 250. But the one thing you got to remember, 250 ends in a 0. That means it's even. So 2 times something makes 250. 250 ending in 0 is also a lot of information to you because any number that's divisible by 5 ends in a 0 or a 5. So 5 times something also makes 250. This number ending in 0 again was special because of the number 10. When you count by tens, each and every one of those numbers end in a 0. So 10 times something also makes 250. So for the purposes of this factor tree, we're going to use the number 5 times 50. Okay? Remember, 5 times 5 equals 25. If you add a 0, we add a 0. 5 times 50 equals 250. Okay? Now I'm going to circle this 5. Remember that circle that we talked about in class? It's like a big stop sign that tells you I'm prime, stop. Don't do anything else to that number. 50 is not prime, it's composite. It's got more than 1 times 50 that multiply together and make 50. We could use 5 times 10. We need to do a factor check and see which of the two numbers I just wrote down is a prime number. If you guess 5, you're right. So I'm going to circle it. 10, what two numbers come together and make 10? Remember, 10 is composite. There's 1 times 10, and if that were it, then it would be prime. But because there are more numbers, it's composite. We're going to use 2 times 5. And when I look at the 2, I know it's prime because only 1 times 2 equals 2. And only 1 times 5 equals 5. Now that I'm looking at all circles, I'm done with my factor tree. Here's the prime factorization. Taking all those circled numbers and putting them together in one long number sentence, like this. 5 times 5 times 2 times 5. Prime factorization. Now I'm going to take my prime factorization and I'm going to abbreviate it. Use some exponents. So I see 1, 2, 3, 5s here. That means I've got a big 5 and a little 3. That exponent tells me that there are 3 of these 5s multiplied together. Times 2. And there's only one of those 2's. So if you want to, you can put a little 1 on top that tells you that there's only one of those. Prime factorization using exponents. Okay? I'm glad hoping that you take notes on this. All of this is going to come in handy. We will continue to use this, and I'll see you just a little bit later for another video. Thanks for watching.
Wait.